Welcome back, everyone. This is Chapter 9, Section 2, where we are talking about two means that are independent of one another. And let's start with that. Two samples are independent if the same values of one population are not related to or somehow naturally paired or matched with the sample values of another population. Hypothesis test of the claim about two independent population means. We are going to assume that sigma sub 1 and sigma sub 2 are unknown, and we're going to assume that they are not equal. And to us, that means not pooled. And I'm not going to get into pooling and not pooling and all that, but we will need that when we use the calculator. All right, we have some requirements. The values of, and I just mentioned this, the two standard deviation, population standard deviations are not known, and we are not going to assume that they are equal, so they're not pooled. The two samples are independent. Both samples are simple random samples, and n sub 1 and n sub 2 are both bigger than 30, or both samples come from populations having normal distributions. And here is the test statistic, the formula for that. It's quite involved. Thankfully, we have machines that will do stuff like that for us. And when we pick the degrees of freedom, there is a much more complicated way to figure out the degrees of freedom, but I'm just going to say, just use the larger of the two, whichever is bigger. And let's get to our example. All right. Assume that two samples are independent, simple random samples selected from normally distributed populations. So we just knock out all the criteria that we need. And do not assume that the standard deviations are equal. The table gives us from a study of the spoken words spoken in a day by men and women. Use a 0.01 significance level to test the claim that the mean number of words spoken in a day by men is less than that of women. All right, so let's write down our null hypothesis. And of course, assume that the means are already equal. And the null hypothesis is that men speak less words than women. I've heard this before, like as an anecdotal thing, but I can't imagine this being true for everybody all the time and all that, especially for someone like me who talks for a living. All right, so let's take a look at what we're going for here. All right, and this is going to be left-tailed because it is less than. And we are testing at the 0.01 significance level. So 0.01%. And let's get some critical values. Now, this is going to be a t-test, so we need n. Actually, our degrees of freedom is going to be the larger, pardon me, the larger of these two. So the degrees of freedom, in this case, is going to be 209. Now, I say that only so that I can get my critical values. So I'm going to use inverse t here. And once again, those of you that don't have inverse t, you will need to use your t table. And you'll have to use 200 because it doesn't go down to 209. All right, now the calculator will automatically, well, let me just show you. Inverse t, area to the left is 0.01. Degrees of freedom, I'm going to say is 209. And our critical value is negative 2.34. Oh, you know what? I put 209 for the, degrees of freedom. That's correct. Negative 2.34 is our critical value. Now for the test statistic. Now we will be running a two sample t-test. Here we go. So we're going to go stat tests, 2 sample t-test right there. And X bar sub 1 is 186. Oh, that's N, pardon me. Oh, and I kicked myself out. 2 sample t-test. All right, X bar is actually here. 1566.8.5. Standard deviation 8632.5. N sub 1 is 186. Here we have 16215. We have 7301.2. 210. Now this is going to calculate the degrees of freedom using that more complicated way, which is fine. It won't affect our answer. Our hypothesis is a less than scenario. And as if it's pooled, and we're going to say no, we're not going to do any pooling for this particular class. And hit calculate. There's my test statistic, and there is my p-value. So let's write that down. All right. Test statistic. T is about, let's see, negative 0.6755. That is going to be about right there. And my p-value is going to be quite large, it looks like. P-value is 0.25, I'll round it off, which is way bigger than the alpha. So we are going to fail to reject. Fail to reject. Let's push that up. No hypothesis. So there is not sufficient to support clean and speak. And women. There it is. Now, I don't know if these numbers are completely made up or if this was a valid study. I don't know how you would even count the number of words someone says in a day, but let's move on. Confidence interval is here. And you can see it gets fairly complicated, but once again, we have a fun, easy way out of this. And our alpha is 0.01, and we're going to run the same information, and we should be able to interpret this nearly exactly the same. So this is going to be a 2 sample interval, t interval. T interval. That test. So 2 sample t interval, there it is. Very nicely, it has all of the data still there. Sea level is 0.99, right? That means here. And now there's something we have to keep in mind with this. When we have a one-tailed confidence interval, which we do, because if you remember the previous one was like this. And if you remember, and it was a one tail. The problem with the confidence interval is it has to be a two tail. And because this is 0.01, what I'm going to have to do is add a second tail. And what that's going to do is that's going to change the sea level from what we thought was a 0.99. No. This is now an 8. So that's the only difference that we got to win. And it only matters when we have a two-tail. I'm sorry, a one-tail, because we need a second tail. So it dropped down by that. So if this was 0.05, then the sea level would be 0.9 and so on. So this is that somewhat weird case. So let's get back to here. And when we go down to our sea level, it's not 0.99, it's now 0.98. Still not pooled. And there we are. So our confidence interval is -2,437. And 1343.8. And here's how we know that we're good. Because our null hypothesis is here, this means that mu sub 1 equals mu sub 2 becomes mu sub 1 minus mu sub 2 equals 0 if it's true. And you can see we go from a negative to a positive, which means 0 is in here. So this is just another way to verify that we are going to fail to reject. So let's make that more clear. So we went from a negative to a positive, which means 0 is in there. All right, so what's our conclusion? It's actually the exact same conclusion that we came to here. I'm not going to write out the whole sentence again, but I will say that we're going to fail to reject. The null hypothesis. All right, and for this last one, for this section, we're going to use both methods. So we have a research project conducted trials to investigate the effects of colors and creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. Judges gave scores corresponding to a creativity marker. The higher score, the more creative. Higher the score, the more creative. The researchers claim that the blue enhances the performance on a creative task. Okay, so blue is getting a larger amount. So let's set up our null hypothesis here. Now blue is the second one here. So it's going to be bigger. So I'm going to say this is 1 and this is 2. So this means mu sub 1 is less than mu sub 2 because the blue is bigger, right? All right. So part A, actually let's draw out what we have here. And we're gonna have that two-tail issue again with the confidence interval, because this one's gonna be one tail again. And it's less than, and it's 0.01. So for our test, and let's find our critical value. So inverse T. Oh, so our degrees of freedom for this are going to be 35 because that's the larger of the two. 0.01 and 35. Right, it's one less than the larger of the two. -2.44. -2.44. And now we're going to run part A. It says we got to get a test statistic, so let's run the numbers. All right, so stat test. This again is a 2-sample t-test. So 3.39, 0.97, 3.97, 0.63, 36. This is a less than again, not pooled. And here we go. Here's our test statistic. So T here is -0.98. Ooh, we missed out, which is right there. We are in the bad zone. P-value. P-value is 0.0021, which is definitely less than 0.01. So doing it this way, we are rejecting the null hypothesis. And I'll write a sentence at the very end for both. Part B says we're going to do the same thing, but we're going to construct a confidence interval, but we got to keep in mind, because it's only a one tail, we got to add this, and that changes our C level 0.98. B, C level should be 0.98 in this case. All right. So if you remember, this is a 2-sample t interval. 2-sample t, there it is, t interval. And all of the data should be the same, but we're going to have to change our C level to 0.98. So that's left over from before. And here we go. So -1.046. -0.1142. And here's the problem, is that we went from negative to negative. Zero's not in there. So in this case, we will reject the null hypothesis also. Again, we went from negative to negative. So no zero. So zero is not between a negative and a negative. So let's, so no zero. So we're going to reject the null hypothesis. The two answers should match. And so there is sufficient evidence to support claim that blue is a little better. Cool stuff.